Hi guys. So I just wanted to show you another type of graph that we use to describe our motion of an object. So this graph is a little bit different than the one in previous videos because in this one you can see that on our y-axis we have speed and on our x-axis we have time. So we would call this graph speed over time, or sometimes it might even be referred to as velocity over time. And so if you were to calculate the slope of this line, that would be your acceleration. So we define acceleration as a change in velocity over time. And in one of the previous videos, you guys learned the equation for velocity, for acceleration was that final velocity minus initial velocity divided by time equals your acceleration. And so this graph is going to mean slightly different things because we're changing the speed over time instead of the distance over time. So when we see a straight line in the forward direction, like we do in section A right here from A to B, this means that it has steady acceleration. So that means that it's accelerating in a very steady way. When you see a horizontal line, what that means is that the speed is staying exactly the same. So that would mean that you are on cruise control. So your speed is staying exactly the same even though time is passing. Again, this is another acceleration. And we can tell that this one is not quite as quick as this one down here because the slope is not quite as steep. So that's why this is referred to as gradual acceleration. When you see a line in the negative direction on the graph, what that really means is that the object is slowing down. So you can see that the speed is decreasing as the time is going further along. So one way to say this is a negative acceleration or a deceleration. Those mean the same thing. So if you want to figure out the acceleration, what you would have to do is to calculate the slope. So let's go ahead and calculate the slope for part D here. And so to calculate the slope, you would need 2 points on the line. And I can see that this point is on a grid line and this point is on a grid line. So those are the 2 points that I'm going to choose. If you wanted to choose this one, that would also be okay. And remember that slope is the change in y. So that little triangle is the delta, which means change in, over the change in x. Another way to say this is rise over run. So how far up or down do we go and how far left and right do we go? Now in this case, because the grid lines are not marked, I'm just going to go ahead and assume that every grid line means 1 meter per second, and then every grid line on the x-axis is going to be 1 second. So our change in y, here's 5, so 6. So our change in y is actually -6 because we're going down. And then our change in x, we have gone over, let's see, we've gone over 1, 2, 3. So -6 divided by 3 would be -2. And this is going to be meters per second, which is kind of a confusing unit for some students. But because you have seconds in the denominator twice, another way to say this, instead of having meters per second, what you can do is you can say meters per second squared. And it should be negative because the object is slowing down.